In the context of spaceflight, a satellite is an artificial object which has been intentionally placed into orbit. Such objects are sometimes called artificial satellites to distinguish them from natural satellites such as Earth-Moon. The world's first artificial satellite, the Sputnik 1, was launched by the Soviet Union in 1957. Since then, thousands of satellites have been launched into orbit around the Earth. Some satellites, notably space stations, have been launched in parts and assembled in orbit. Artificial satellites originate from more than 40 countries and have used the satellite launching capabilities of 10 nations. A few hundred satellites are currently operational, whereas thousands of unused satellites and satellite fragments orbit the Earth as space debris. A few space probes have been placed into orbit around other bodies and become artificial satellites to the Moon, Mercury, Venus, Mars, Jupiter, Saturn, Vesta, Eros, Ceres, and the Sun. Satellites are used for a large number of purposes. Common types include military and civilian Earth observation satellites, communications satellites, navigation satellites, weather satellites, and research satellites. Space stations and human spacecraft in orbit are also satellites. Satellite orbits vary greatly, depending on the purpose of the satellite, and are classified in a number of ways. Well-known classes include low Earth orbit, polar orbit, and geostationary orbit. About 6,600 satellites have been launched. The latest estimates are that 3,600 remain in orbit. Of those, about 1,000 are operational, the rest have lived out their useful lives and are part of the space debris. Approximately 500 operational satellites are in low Earth orbit, 50 are in medium Earth orbit, the rest are in geostationary orbit. Satellites are propelled by rockets to their orbits. Usually the launch vehicle itself is a rocket lifting off from a launch pad on land. In a minority of cases, satellites are launched at sea or aboard a plane. Satellites are usually semi-independent computer-controlled systems. Satellite subsystems attend many tasks, such as power generation, thermal control, telemetry, attitude control and orbit control. History. Early conceptions. Newton's cannonball, presented as a thought experiment in a treatise of the system of the world by Isaac Newton, was the first published mathematical study of the possibility of an artificial satellite. The first fictional depiction of a satellite being launched into orbit is a short story by Edward Everett Hale, The Brick Moon. The story is serialized in the Atlantic Monthly, starting in 1869. The idea surfaces again in Jules Verne's The Begum's Fortune. In 1903, Konstantin Tsiolkovsky published Exploring Space Using Jet Propulsion Devices, which is the first academic treatise on the use of rocketry to launch spacecraft. He calculated the orbital speed required for a minimal orbit around the Earth at 8 km per second, and that a multi-stage rocket fueled by liquid propellants could be used to achieve this. He proposed the use of liquid hydrogen and liquid oxygen, though other combinations can be used. In 1928, Slovenian Herman Potocnik published his sole book, The Problem of Space Travel, The Rocket Motor, a plan for a breakthrough into space and a permanent human presence there. He conceived of a space station in detail and calculated its geostationary orbit. He described the use of orbiting spacecraft for detailed peaceful and military observation of the ground and described how the special conditions of space could be useful for scientific experiments. The book described geostationary satellites and discussed communication between them and the ground using radio, but fell short of the idea of using satellites for mass broadcasting and as telecommunications relays. In a 1945 Wireless World article, the English science fiction writer Arthur C. Clarke described in detail the possible use of communications satellites for mass communications. Clarke examined the logistics of satellite launch, possible orbits and other aspects of the creation of a network of world-circling satellites, pointing to the benefits of high-speed global communications. He also suggested that 3 geostationary satellites would provide coverage over the entire planet. The U.S. military studied the idea of what was referred to as the Earth Satellite Vehicle when Secretary of Defense James Forrestal made a public announcement on December 29, 1948, that his office was coordinating that project between the various services. Artificial satellites. The first artificial satellite was Sputnik 1, launched by the Soviet Union on October 4, 1957, and initiating the Soviet Sputnik program, with Sergei Korolev as chief designer. This in turn triggered the space race between the Soviet Union and the United States. Sputnik 1 helped to identify the density of high atmospheric layers through measurement of its orbital change and provided data on radio signal distribution in the ionosphere. The unanticipated announcement of Sputnik 1's success precipitated the Sputnik crisis in the United States and ignited the so-called space race. Within the Cold War, Sputnik 2 was launched on November 3, 1957 and carried the first living passenger into orbit, a dog named Laika. In May 1946, Project RAND had released the preliminary design of an experimental world-circling spaceship, which stated, "A satellite vehicle with appropriate instrumentation can be expected to be one of the most potent scientific tools of the 20th century." The United States had been considering launching orbital satellites since 1945 under the Bureau of Aeronautics of the United States Navy. The United States Air Force's Project RAND eventually released the above report. In 1954, the Secretary of Defense stated, "I know of no American satellite program." In February 1954, Project RAND released Scientific Uses for a Satellite Vehicle, written by R.R. Carhart. This expanded on potential scientific uses for satellite vehicles and was followed in June 1955 with the scientific use of an artificial satellite by H.K. Kalman and W.W. Kellogg. In the context of activities planned for the International Geophysical Year, the White House announced on July 29, 1955 that the U.S. intended to launch satellites by the spring of 1958. This became known as Project Vanguard. On July 31, the Soviets announced that they intended to launch a satellite by the fall of 1957. Following pressure by the American Rocket Society, the National Science Foundation, and the International Geophysical Year, military interest picked up, and in early 1955 the Army and Navy were working on Project Orbiter, two competing programs. The Army's, which involved using a Jupiter-C rocket, and the civilian, Navy Vanguard rocket, to launch a satellite. At first, they failed. Initial preference was given to the Vanguard program, whose first attempt at orbiting a satellite resulted in the explosion of the launch vehicle on national television. But finally, 3 months after Sputnik 2, the project succeeded. Explorer 1 became the United States' first artificial satellite on January 31, 1958. In June 1961, 3.5 years after the launch of Sputnik 1, the Air Force used resources of the United States Space Surveillance Network to catalog 115 Earth-orbiting satellites. Early satellites were constructed as one-off designs. With growth in geosynchronous satellite communication, multiple satellites began to be built on single-model platforms called satellite buses. The first standardized satellite bus design was the HS-333 Geocomsat, launched in 1972. The largest artificial satellite currently orbiting the Earth is the International Space Station. Space Surveillance Network. The United States Space Surveillance Network, a division of the United States Strategic Command, has been tracking objects in Earth's orbit since 1957, when the Soviets opened the space age with the launch of Sputnik I. Since then, the SSN has tracked more than 26,000 objects. The SSN currently tracks more than 8,000 man-made orbiting objects. The rest have re-entered Earth's atmosphere and disintegrated, or survived re-entry and impacted the Earth. The SSN tracks objects that are 10 centimeters in diameter or larger. Those now orbiting Earth range from satellites weighing several tons to pieces of spent rocket bodies weighing only 10 pounds. About 7% are operational satellites, the rest are space debris. The United States Strategic Command is primarily interested in the active satellites, but also tracks space debris which upon re-entry might otherwise be mistaken for incoming missiles. A search of the NSSDC master catalog at the end of October 2010 listed 6,578 satellites launched into orbit since 1957, the latest being Chang'e. On the 1st of October 2010, non-military satellite services. There are three basic categories of non-military satellite services. Fixed satellite services. Fixed satellite services handle hundreds of billions of voice, data, and video transmission tasks across all countries and continents between certain points on the Earth's surface. Mobile satellite systems. Mobile satellite systems help connect remote regions, vehicles, ships, people and aircraft to other parts of the world or other mobile or stationary communications units, in addition to serving as navigation systems. Scientific research satellites. Scientific research satellites provide meteorological information, land survey data, amateur radio, and other different scientific research applications such as earth science, marine science, and atmospheric research. Types. Astronomical satellites are satellites used for observation of distant planets, galaxies, and other outer space objects. Biosatellites are satellites designed to carry living organisms, generally for scientific experimentation. Communications satellites are satellites stationed in space for the purpose of telecommunications. Modern communications satellites typically use geosynchronous orbits, molniya orbits or low Earth orbits. Earth observation satellites are satellites intended for non-military uses such as environmental monitoring, meteorology, map-making, etc. Navigational satellites are satellites which use radio time signals transmitted to enable mobile receivers on the ground to determine their exact location. The relatively clear line of sight between the satellites and receivers on the ground, combined with ever-improving electronics, allows satellite navigation systems to measure location to accuracies on the order of a few meters in real time. Killer satellites are satellites that are designed to destroy enemy warheads, satellites, and other space assets. Manned spacecraft are large satellites able to put humans into an orbit, and return them to Earth. Spacecraft including spaceplanes of reusable systems have major propulsion or landing facilities. They can be used as transport to and from the orbital stations. Miniaturized satellites are satellites of unusually low masses and small sizes. New classifications are used to categorize these satellites. Mini-satellite, microsatellite, nanosatellite. Reconnaissance satellites are Earth observation satellite or communications satellite deployed for military or intelligence applications. Very little is known about the full power of these satellites, as governments who operate them usually keep information pertaining to their reconnaissance satellites classified. Recovery satellites are satellites that provide the recovery of reconnaissance, biological, space production and other payloads from orbit to Earth. Space stations are man-made orbital structures that are designed for human beings to live on in outer space. A space station is distinguished from other manned spacecraft by its lack of major propulsion or landing facilities. Space stations are designed for medium-term living in orbit, for periods of weeks, months, or even years. Tether satellites are satellites which are connected to another satellite by a thin cable called a tether. Weather satellites are primarily used to monitor Earth's weather and climate.